fine, it's fine, it's fine. Guys, please remember that as soon as you are done with your exams, we are starting to prepare for the next year. Trust me, honorable members, if you take this seriously, you are definitely going to be far. Okay, let me see there. I'm not really sure in terms of what's going on over there. Let me say done. Okay, it looks like we are live on YouTube. Okay, now what I need to do, I think it is to share my screen. Yeah, so what I was saying, the honorable members, is that I hope you guys did hear this part. You say starting after your exams, most probably middle of December, starting to prepare for the next year. So meaning by then you should be having your report. Otherwise, we will prepare anyway. You'll be studying ahead. Just so that come next year around the same time, you are fully ready. You are fully equipped to attack any question that will come your way. And now I need to share my screen. Let me do that. Share screen and then say start. I think my screen is sharing. So very quickly, honorable members, very, very quickly, we can try to discuss this question. So here we have a question which says 2 blocks of mass 8 kg and 4 kg respectively are joined with an inelastic string of negligible mass. The string runs over a frictionless pulley. The 8 kg block is on a horizontal surface that we can see, while the 4 kg block is on an inclined plane of 40 degrees with the horizontal. Yes, that makes sense. We can see that on the diagram. The coefficient of kinetic friction for both blocks is 0.2. The 4 kg block accelerates down the slope. Okay. So without us having to go through the questions, one thing for sure, there's no way they are talking about a applied force. But one thing for sure, that 4 kg block accelerates down the slope. Possibly it is accelerating because of or as a result of force by gravity, not necessarily because there was an applied force which pushed it in that direction. These are some of the things that we can say before we get to the questions. But when we get to the questions, if an applied force is introduced in a form of a question, then it means we will have to now look into that differently to say, okay, in the statement, they did not say anything about the applied force, and it may be introduced in a question. But by the look of things, we won't have an applied force in that case. So 4.1, state Newton's second law of motion in words. By now, you should be able to state Newton's second law, honorable members. It's not necessarily something that we teach, but what we can tell you is that Newton's first, second, and third law, it's something that you should always know by heart. And then it ends there for that question, honorable members. But that 4.2, for example, where they say you need to draw a labeled free body diagram of all the forces acting on the 4 kg block. You see now, on the 4 kg block. Now, makes it very much easier, very, very much easier, honorable members, if you've got your nice, let's say, looks like we'll need to increase size of that. Okay, let's see. Okay, let's see, you've got that over there, honorable members. I'm sure you do remember very well that I did say that it's best if you just cut it somewhere there, honorable members. If you just cut it right there in the middle, then you can separately draw for that if it is required, or separately draw for that if it is required, of which in this case, they want you to draw for the 4 kg block. One thing for sure, honorable members, we start with that force that will always be there. Which one it is? It is the force by gravity. That is number one. Number two, if this object, it is on a surface, you are forced to draw a normal force. Very, very much important, honorable members or members who are honorable. And then now, taking into consideration that this question is allocated 4 marks, possibly we've got 4 forces acting on that object. An obvious one, it is the frictional force. How do I know? Because there is a kinetic friction. We are given the coefficient of that kinetic friction. Also, these two are connected by a string. We are therefore forced to have that tension force. Remember to make sure that your lines are straight. So you need to use a ruler to draw those straight line forces. Okay, so guys, I'm not sure. Does it make sense up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, 100%. So, now we move on to the next question, which says calculate the frictional force between the surface and the 4 kg block. Let me just check if there's anyone who would like to suggest how we can work it out. Anyone who can suggest how we can work it out? You see, now we are at a point where we are doing the calculations. Anyone who would like to give it a try? Or just suggest how we can work it out? In case if you've got no idea, please do mention and say no idea so that we do not waste our time on that one.
Sir, can I try?
Yes, go for it, honorable member.
Okay. So since the frictional force is on the it's on the horizontal axis, on the x-axis, we are going to basically focus on that, on the x-axis. So so we have to first create our own formula, and since it's Newton's second law, we're going to use the formula F net is equals to ma.
Okay.
I'm going to choose my right hand side as my
Positive.
sorry, since it's going down, I'm going to choose my left side as what am I as my positive, sorry, as my positive. So I'm going to say FK
Okay.
minus oh I forgot my story. Can I just draw my own body diagram because I don't understand yours,
Okay.
sir?
Okay. You can quickly work it out on your side. But now, how does your labeled free body diagram look like? Is it different from mine?
My F is going to be on my it's going basically, I don't know how to show it, like it's going down it's going down to the right side, to my right side. Yeah, like
So this is southeast,
yeah.
if you are doing geography. So you say what is the name of that force that goes in that direction? What is it?
I said just FK.
FK meaning the
Frictional
frictional force.
yes, sir.
Okay.
So after that, you're going to subtract tension.
Okay.
And since it's an inclined plane, we are going to break it down to its components. So yeah, we're going to break FG into its X and Y components. So since we're focusing on the horizon, on the horizontal, on the x-axis, we are going to say minus FG parallel is equals to MA.
Okay. Let's continue.
After that, you're just going to basically substitute the information that
Okay, I see.
that they've given you, basically.
But do we have the tension?
No,
We don't have. Do we have FK?
we don't, but we have its coefficient.
We have its coefficient, but we will still need something because yeah, maybe let me just correct you straight away, Sinit, because I see a very serious danger there. What is this? Do you agree this is actually frictional force?
I think I misunderstood the question. Can I try again, sir?
Okay, it's fine. I will work it out, but I just want us to now discuss this one because that's a big mistake there. The frictional force will always oppose the direction of the motion. So this thing, this system is flowing in that direction. So the friction can't be in the same direction as the motion. I'm not sure if you get this part is in it.
Yes, I
So
do
it's,
understand, sir.
yes, it's like we're having object and then they are saying there is the force applied and then it's on a rough surface. So you are saying the frictional force is in that direction. Can you see that this one is highly impossible? Can you see?
Yes, sir.
So I'm not sure. Do you still remember Mahona Jotli?
Yes, sir.
That, that's what you must always do, honorable member. Trust me, if you don't apply that approach, you will at all the times be confused. Let me show you.
But sir,
Mhm.
they didn't give us the force applied, did they?
No, they didn't. That is because
So shouldn't
it's not there, and if it's not given, um, it means it doesn't need to be there. We don't need to make it to be there. What did you want to say?
so I was like, shouldn't if they didn't give us the force applied, shouldn't the frictional force be where I said it should be, because they didn't give us any force applied. So against what is the frictional
No,
force opposing?
no,
Like what force is the frictional force opposing?
no. I hear what you are saying. Take your book, take your book, put a calculator on it. Let me know after you've done that.
Yes, sir.
Yes, tilt your book from the other end, for example, such that it is now at that angle. What happens? Did you hear that sound? What happened?
It fell.
It
Well,
fell.
it slipped down, yeah.
Yes, not because you pushed it, isn't it? Not because there was an applied force, but it fell because of that force of gravity parallel. So in a way, indirectly, this is an applied force, but by gravity. So that means in this case, there is no need for an applied force, but still this object is going to move. So that is why the frictional force will oppose that movement.
Okay, sir.
So you will never ever have frictional force in the direction of the movement of the object. The frictional force does not oppose the applied force, it opposes the movement. Always remember it this way. Did you hear me there, Sinit?
Yes, sir.
Okay, repeat what I said based on your understanding. What did I say, Sinit?
So basically, if they didn't give us the force applied, it they still like they still force that opposes the object, because even though you don't apply force onto the object, they still there's still opposition to its movement.
Okay, let me say it again, maybe differently. So, all these forces are independent. So, for example, if we talk about frictional force, we don't need to compare it to applied force. If there is a frictional force, can you hear me on this part, Sinit? If there is a
Yes, sir.
frictional force, it will always oppose the movement of the object. So what I'm saying is, if there is an object, if this object is moving in that direction, the frictional force, if it exists, then it will be in the opposite direction of the movement, not in the opposite of the applied force, not in the opposite of FG, not in the opposite of tension. We don't compare force by force. We're just saying frictional force will always oppose the movement. So every time you come across an object, ask yourself, in which direction is it moving? Is it moving towards the right or left? If it's moving towards the left and the surface is rough or there is friction, then it's in the opposite direction. If the object is moving towards the right and they said the surface is rough or there is friction, just know it's opposing the movement, not that it is opposing the applied force. Do you guys hear me on that one? Am I not confusing you?
No, sir.
Sinit, does it make sense, honorable member?
Yes, sir. So just to clarify, it doesn't oppose the force, it opposes the direction in which the object moves.
100%, exactly that.
Okay, thank you, sir.
Okay, so let's go back to Mahona Jotle, honorable members. Let's go back to Mahona Jotle. What did I say? I said we've got those that we can refer to the vertical forces. I'm not sure if you guys remember. I'll need that formula from you. We said F net, let's say for the verticals, it's equals to MA. And again, we said F net for the horizontal forces, it is equals to, again, we said MA. Do you guys still remember this? Check it from your notes, where we said we can have a drawing or a free labeled body diagram for the purpose of calculations. Do you guys still remember, Mar? Where
Yes,
if
sir.
we have tension in that direction, and again we have a friction in that direction. I said if we have a normal force in that direction, then let's have its component, the FG perpendicular. And again, let's have the FG parallel. So I said this is for the purpose of answering that question of a free body, a free labeled body diagram. But this one on the other side, it is for the purpose of calculations. And before you get to calculations, start with Mahona Jotle. That's why I'm saying if you follow my method, honorable member, you will never go wrong. Remember, sometimes in school, they teach by answering that specific question. But what I'm teaching you, especially in other topics, it's something that will be applicable to all the questions. So you just need more practice in order to master this. And it's the only way. Okay, what did we say about the F-net for the verticals? Do you guys still remember? Did we not say we can take normal force as positive because it's going in that direction, meaning this other one, it will be negative, meaning we have minus a FG perpendicular, and we said this will therefore be equals to MA. What else? On the other side, we can therefore say we have FG parallel, we take it to be positive, that one. So that means this was positive, that was negative, this will be negative, this will be negative. Meaning we have positive FG parallel, we minus that FK, we are also going to minus the tension, and then this will therefore be equals to a MA. I'm not sure if you guys remember. Anyone who still remembers this as our Mahona Jotli? Do you guys still remember?
Yes, sir.
Yes, sir.
Okay, then it's fine. Let us expand this formula. We said we have normal force. What was FG perpendicular? It's MG. This is it the one for cos or is it the one for sine?
It's the one for cos, sir.
Okay. Cos of an angle, then it's equals to MA. So that means this one is the one for sine. So we have MG sine of an angle minus that thing of frictional force minus the tension, and then that is equals to MA. So
Sir,
it doesn't end there, yebo.
you can still break down FK into its formula.
100%. Maybe let me include it there. Let me maybe include it there, even though I did not want to. Okay, it's fine. Okay, it's fine. Let us include it. What is it? You remember it's mu, ne? Mu normal, then minus tension is equals to MA. This is what you are referring to, Sini.
Yes, sir.
Good test. Okay, so now, eh, let us try to remember something. Do we not have the formula for calculating a FK? Anyone who knows that formula? I think Sinit, you gave it the previous time. Do we not have that formula for calculating
FK,
UKN.
is that one, sir? UKN.
mu n?
K, sir.
Okay, mu kn. You can also edit there. Okay, it's fine. 100%. Again, do we not know the formula for n? The formula
So
for
it is
n,
FG.
it's equals to a mg. or N could be equals to that a FG parallel, meaning it's going to be mg cos of an angle. That's if it is on an incline. But if it is on a horizontal surface, this is the formula. So it's just a matter of knowing between these two, which formula are you going to use? It looks like we're going to use the one for the component. Can you see on our labeled free body diagram, unlike this one, which is on a horizontal surface, we were not going to have the component, but we were just going to have FG. So that means N, it's equals to FG. So in short, what I'm saying, honorable members, what I'm saying is we do have, this is the formula that we're going to use, by the way. How are we going to go about that? Let's agree, do we not have this value? We do have it. What about N? Between these two formula, which formula are we going to choose? Because we already know that our mu is 0.2. But in terms of N, which formula are we going to use? Are we going to go for the one for mg or the one for mg cos angle?
mg cos angle.
Why the one for mg cos angle and not the one for mg? The reason is because the object that we are dealing with, it is at an angle. That is the simplest reason. Does it make sense?
Yes, sir.
Yes, sir.
Yes, sir.
So that means if the object was not at an angle, we were not going to use the one that has an angle. So that is why now we are going to say, we know what is the mass? What is the mass? It's the mass is 4. We need to multiply it by a g, and then we need to say cos of an angle. Then you punch all of that on a calculator. That's how you get the answer for that question. But does it make sense, honorable members?
Yes, sir.
Are you sure?
Yes, sir.
I did not confuse you
100%.
on that one.
No confusion, sir.
No confusion. Remember, your 4 marks comes from you giving the correct formula, correct substitution for both. Maybe let me put it then, say correct substitution and then correct answer plus the direction. What will then be the direction? Let's say you punch all of this, you get an answer. What are you going to say for the direction? Because this is a vector quantity. It needs both magnitude and direction. What are you going to say in terms of direction?
Up the slope.
100% up the slope, because it is acting towards that upward direction. Why? Because the movement is in that direction. So you need to give that a direction. Guys, we are okay on that one, Moss. We can move on.
Yes, yes, sir.
Okay. Yebo.
Can you please explain on how do you determine in which direction to say after you get your final answer? Like now you said
so,
up the incline. So like how do you determine that?
okay. You remember, it is the friction that we are trying to calculate, isn't it?
Yes, sir.
Yes. Which direction is the object moving? Is it up the slope or down the slope?
I believe it's down the slope.
Then the friction will always oppose the direction of the movement of the object. You remember?
Yes, sir.
So what will then be the direction of that frictional force?
Up the slope.
Yes, that's how you determine it. You just need to know in which direction is the object moving. Is it towards the right? If it is towards the right, then it means your direction for friction, you're going to say towards the left. For example, if it was that 8 kg, if it is moving towards the right, that means its friction will be towards the left. But this one is down the slope. That means the friction opposite up the slope. Does it make sense?
Yes, sir. Thank you, sir.
Yes.
Yes, sir.
Okay, so now moving on to that question, 6 marks. This is a question which is likely to come in case if you are given a system similar to that. And this is where you will need a mahona jotle. So now, let's see, anyone who can suggest how we can work out that one way, you need to calculate the magnitude of the acceleration of the system. Anyone who's got an idea on that one, honorable members or members who are honorable?
Sir, wouldn't you use F net is equal to MA? And then
Mm-hmm.
and then you break F net into its components.
Mm.
So yeah, you break it down into its components and then you solve for acceleration.
But since we have two formulas there, which formulas are we going to use?
So wouldn't we use the one that's perpendicular to the surface, not parallel? I mean, no, the parallel one.
The parallel one.
Yeah, so the parallel one.
Okay, let's see if we use the parallel one. Okay, do we have M? Yes, we do have M, isn't it? Do we have G? Yes, we do have G. A sine angle. Do we have angle? Yes, we do have an angle. Nay. And then, do we not have that part? We do have that part. Do you guys agree with me on that one? Which is that, what we just calculated? Do you guys agree with me on that one up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Tension, we don't have tension. We don't have the value for the tension. Let's just leave it for now. On the other side, we have the mass. But this is what we are trying to calculate. So the Alice, can you now see we've got a problem? Now we have two unknowns on that equation. Can you see?
Sir, can't you use simultaneous equations to solve for acceleration then?
But why would you then have to apply the simultaneous approach?
I don't know, sir, because like we were told that sometimes you'll need to apply it to solve for things that you need. And so I just assumed that because we can apply it, we should apply it in this scenario.
Sir,
Yebo.
isn't it because you basically make one, if you have two unknown variables, you make one of them the subject of the formula. So because we have two masses here, we basically find the since you said we don't have acceleration as well as
The
tension, we first create a formula for both masses, right? And then usually what I do is if I'm finding for acceleration, I make T the subject of the formula. So after I find the equation for T for both masses, I equate them, and then I use simultaneous equation to solve A, because that way it gets rid of one unknown variable while helping me find the unknown variable that they're asking me for. I hope that makes sense.
exactly what you said. You've answered my question. The Ma'alis, yes, there's going to be a need to work it out simultaneously, but you will then need to remember that these two things are connected by that string. So it therefore means this is where you need to cut it. If you remember, we just did a labeled free body diagram for that. So now you need to do separately for this one. What you must know is that the reason why you use simultaneous equation, it's because this tension is experienced the same by both objects, but in opposite directions. For example, this string on the 4 kg, it is actually pulling it in that direction. That's after you've separated it. But on the 8 kg, it is in that direction. It is pulling the 8 kg, but it is pulling the 4 kg. Do you guys understand that part? What I've just explained to say this is tension 1 for the 8 kg, and then this is tension 2 for the 4 kg. Do you understand those arrows, that, honorable members? When I say on the 8 kg, it is pulling, but on the 4 kg, it is also pulling. Same amount of tension, but in opposite directions.
Yes, sir.
Yes, sir.
Yes. So we've already done a free labeled body diagram for that. We now need to do for the 8 kg. Very quickly, let's do it. So that means you've got that 8 kg. We have that friction in that direction. And then towards the right, it is just the tension that we have. Those ones for the up and down, we know they cancel each other. Because in this case, this thing is not at an angle, meaning it's not moving at an angle, but it is moving horizontal. So now we need to do the Mahona Jotle for this 8 kg. How or what will Mahona Jotle look like? So that means we are going to say, remember, F net equals MA, meaning towards the right, we've got tension. Frictional force will always oppose that one. That one being that which is supposed to be equals to MA. But now, would you guys agree with me to say for this one, it might be different? Because already we just know that this is how the formula looks like. Mu and then F a G. But the question is, this FG, which one between those two are we going to use? Wait. I think I have to correct something and say it's actually mu n. No, I want to do that. It's mu n, this thing. It's mu n. So my question is, for that n, which formula are we going to use between these two? And why? The one that you are choosing. For the 8 kg block. Guys, are you still there?
Yes,
or am I
sir.
moving too fast?
Sir, I'm still here.
Yeah, so my
Same here, sir.
question is, which n are we going to use for the
The
8
first
kg?
one. The first one.
Why the first one?
Because it's on like a straight level in a way.
So you remember
There's
the
no
easiest
angle.
way, Chiro, the easiest way was to say it's not at an angle. That's why we don't use the one with an angle between those
Say,
two.
say
You
it's
remember?
mono.
Your explanation is correct, Chiro, but
It's mono, sir.
oh yes, Muano. Evan Muano. Yeah. Muano, you are
Yes, sir.
back. Yeban. Yeban. Bole ka munna Muano man. Ndekare. Kana no ring watenda ka laptop because of but you know the thing is you're not
Yeah.
able to speak. You see now.
I
Okay,
can
welcome,
now.
honorable member.
Thank
Good,
you,
good,
sir.
goodest. But everyone, do you agree there with Muano?
Yes, sir. Makes sense.
Yes, sir.
Yes. So you need to be careful when it comes to that part to say this object is at an angle. So always remember that the FG that you are supposed to use, it will be that of the component that has cos or sine. But on this one, it is not at an angle. It's not on an incline. You won't need the cos angle or the that. So now, can you see this thing? You know which one to use. For that object, you already have the mass. And then this part, you can work it out. This one we are given, so that means we are sorted there. And then now this is the part where Sinit was saying, to say, I will therefore need to make this the subject of the formula on that equation for the 8 kg. I will also make this the subject of the formula for this one of the 4 kg. Then once you've made those two the subjects of the formula, then you equate them. Then that's how you'll be able to mathematically get the acceleration. That's how you work it out. Do you guys understand there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then it is fine. Maybe very quickly we can look at that question. The last one says, how will the acceleration compare if the positions of the 8 kg block and the that are switched? Will the acceleration increase or decrease, honorable members, if you swap those objects in terms of their positions? It just has to physically make sense. It just has to physically make sense.
Sir, it will increase.
It has to. Even if we might not physically or by physics be able to give the reasonings to that, of which you expected to know the reason, but physically, by just looking at that, if you take the 8 kg and put it where the 4 kg is, the acceleration is going to increase. What will then be the physical reason or the reason that will be physically accepted? How are you going to reason on that?
Sir, wouldn't you say that the force of gravity would increase since the mass is increased from 4 kilograms to 8 kilograms, making the acceleration increase?
So the gravitational force will increase. How will it increase? Is because Fg is equals to m. Wait. Fg is equals to ma. Yes, the m increase, and that will lead to an increase in the frictional force. Yes, that should be an acceptable reason, honorable members. That should be an acceptable reason. Or one can still say maybe that is because the net force increase, because we know that if the net force increase, then the acceleration will increase. Or if the component parallel to the slope increase, then that also serves as a reason. Yeah, something of that nature. But did you guys understand how to analyze this type of a question where there is a pulley there, honorable members?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then it's fine. Then it's fine. It's fine. It's fine. You also have something which looks like that one, which might also need to look into. But let's see, maybe very quickly. Okay, question 3. A hovering rescue helicopter has a container of supplies with a weight of that hanging from a cable. The tension in the cable is that. Wait, let's see. We have a hovering rescue helicopter that has a container of supplies with a weight of 1,900. Okay. Hanging from a cable. The tension in the cable is 2,100 newtons. Okay. Now they say state Newton's first law of motion in waves. Again, you see, you need to know Newton's first, second, and third laws by heart. You just need to know those. A body will remain in its state of rest or motion at a constant or uniform velocity unless a non-zero resultant, otherwise net force, acts on it. You just need to know that by heart. Okay, so now they're saying draw a labeled force diagram of all the forces acting on the container. A hovering risk is a complaint. Anyone to describe how we can draw a labeled free body diagram for that one?
So it's FG going down.
Okay, we have FG going down.
And then we have tension going down.
We have tension going down.
Yeah, that's all I can see.
Okay. Another one. Who was speaking there? Was it you, Chiro?
Yes, sir.
Okay. Another one.
Sir, for me, certain FG is from the waist is fine downwards, but for me, tension will have to be upwards. That's what I believe.
Okay, so we have that being FG, and then we have the tension going up. This is what you are saying.
Yes, sir.
Okay, another one, or do you agree with the blue or green?
So I agree with blue for some reason.
Agree with blue for some reason. Anyone else to say something there?
So I'd say blue because the tension on the rope is connecting upwards towards the helicopter, but the gravitational force always acts downwards.
Okay, a very good reason there. Chiro, can we speak the honorable member? Are you still there?
Yes, sir.
Now let's talk. We are drawing a labeled free body diagram of what?
Of the container.
Of the container. Okay. If now this is the container, which forces are acting below the container?
Weight.
Do we have another force acting below the container, below there?
No, sir.
Okay, do we have any forces acting above the container?
Yes, sir. Tension.
Yes. Can you see?
Yes, sir.
So this would apply if you were drawing a labeled free body diagram of the helicopter.
Okay, sir.
But again, let's see. Yes, because it's going to be the weight for the contain, for the weight for the that, and also the tension in that direction. Yes, something of that nature. Yeah. But now, honorable members, how is it the case that this thing is allocated 3 marks and we just have 2 marks? It wouldn't make sense because this helicopter is not going up or down. It is just hovering at that point there. And the weight, we were just told that the weight of the container is 1,960 Newton. And then this one in the upward direction is 2,100 Newton. So possibly there is another force that is pushing downwards. There is another extra force, honorable members, in the downward direction. What makes that force to exist? It's either you write it there, it's fine, or you can still represent that force there. There is that extra force. Let's maybe call it Fy. What will that extra force be? Which forces this object not to move up and down? I'm not sure if you guys understand, but it's like if
stationary force.
What did you say there? I'm going to call 10,111. Yeah, stationary force. And I'm sure him one. To show him one. Stationary force. Near. I'll give you an example. It's like Fg it's equals to a 4 Newton. And then they said the tension it's equals to 6 Newton. If we've got a situation where the forces are not balanced, it means this object is going to go up because the upward force is greater. But according to that statement, this container is not going up, it's not going down, it's just stationary there. So that means there is an extra downward force. So my question now is, how much is that downward extra force?
So it's 2 newtons.
Yes. So that means that extra downward force, it is going to be 2 Newton. We may not know what that extra force comes from, but we just know there is that extra downward force so that this up and down forces balances so that this thing is stationary. So that's why this question is allocated 3 marks. So you don't just look at that and you conclude to say, okay, it's the tension and Fg, but indirectly, examiner is trying to tell you something there by giving you those two different values. I'm not sure. Does it make sense, honorable members?
Yes, sir, makes sense to me.
To the other honorable members, does it make sense?
Yes, sir.
Yes, sir.
So, you might find that these blades are the ones that are adding an extra downward force on that system. Because remember, this tension in the upward direction, it has to carry this helicopter itself. And again, this hovering blades, they also need to be balanced by that tension force. Because those blades, they possibly add as an extra downward force on that system. Or on the container, even though this tension is connected to the helicopter and the helicopter is connected to those blades. But one thing for sure, there is that something that is adding an extra downwards. So that is why when you draw that labeled free body diagram, I'm saying it might be best to say, okay, if this is my container, all the forces that are acting below, it's only one, which is that one being Fg. And then I also have this one of the tension in that direction. If the forces were balancing, then you leave it as it is. But because these forces are not balancing, and because they said this thing is not moving up or down, and this one is 2,100 Newton, this one is, let's say, 1960 Newton. That means there must be an extra downward force. So that's why you show it above, because this extra downward force, it's safer for you to say Fy, because it's the force in the y-axis. That force is acting downwards and it's above that container. That's why it will be best to show it that way instead of showing it this way, as if that force is acting below the container. Do you guys get my point on that one, honorable members? Does it make sense to all of you?
Yes, sir. Sir,
Yes, sir.
Yes, sir.
Yes.
so can I clarify something? So basically, it's like a balancing force.
Yes. It's like a balancing force. How do we know there's a balancing force, Moana?
Because when you add and when you subtract, you get the difference, which is 140. But then when you add that 140 to the FG, it balances out it kind of like, yeah, balances out the weight of both the container and the helicopter.
But what gave us a hint that there must be that balancing force?
They told us
So it's because this container is not moving up or down. It's not moving up and down. It's just hovering at the same point. So that gives us a hint to say, okay, then it means the forces must balance because this thing is not moving up or down. So that's the hint that we have to know that there is an extra force. I'm not sure if you understand what I expected you to say, Moano, as a hint.
Yes. Yes, sir.
Yes. So that means, honorable members, I'm sure, Sinit, especially yourself, honorable member, you are now exposed to how information can be hidden. It will not always be directly, but they will somehow try to hide it either in the statement or in the drawing. And you just need to make sure that whatever that you do, it just has to make physical sense. It has to make physical sense. Guys, I think on my side, we can leave it here, honorable members. You might need to also visit all the other questions that we have gone through just to check or remind yourself in terms of how do you analyze this and all of that. But trust me, honorable members, as we do some more or as we go deep into these things, they will make sense, especially when we do them at our suitable time, not necessarily now because we are rushing for the exams. But I'm pretty much sure that those that we started early this year, we actually started last year, you are not under that much pressure to absorb all this information. But in case if you are having some light, but you can't connect the dots, not worry that much. Just make sure that as soon as you're done with the exams, when we start, you are there and ready to start. Guys, I'm now going to run away. Any questions from your side based on what we discussed? In case if you need
no
clarity.
questions on my side, sir.
No questions, sir.
No one is confused.
None from me, sir.
I did not confuse anyone.
Yes, sir.
No, sir.
Okay, then it's fine. All rise in court. Court is adjourned. Guys, I'm just erasing all of this so that next time when we use this same question paper, it doesn't have this thing. So, guys, court is adjourned. Yegan Khan. Chivo,
Good
is
night,
it the
sir.
right way to say you can leave? Yegan Khan. Sinit. Yegan Khan.
Thank you, meneer.
Am I correct in saying Yegan Khan?
Yes, sir.
Wow. I just know, yeah, sometimes when you speak Afrikaans, there and there you must just throw in a wow. Yeah, those who know, they know. Those who know, they know. Moano, do you know that you should just throw in wow there and there?
Sir?
No, you don't know. Sinit.
No, sir, I didn't hear what you said.
Alice, do you know what I'm talking about, honorable member? I'm not sure if Mentlonke does.
Oh, heavens no, sir. I don't know, sir.
Okay, just listen to your Afrikaans teacher, honorable member. Sometime, yeah, it's like in English or in whatever when you say, oh, Yeah, that, oh, wow. Okay, guys. Ekano.